Hello everyone, welcome to the Chemistry IGCSE series. Today, I'll be solving the February-March 2019 Chemistry Past Year paper, paper 2. Now let's begin. Alright, so for the first question, as you can see the word pure water boils at 100 Celsius. As you can see this word, it means it's a change of state of liquid to gas. So normally in gaseous state, the particle will move further apart from each other. So B and D is wrong. Normally boiling involves the addition of heat. So the particles will definitely gain energy. So question 1, it's A. Or question number 2, which method should be used to separate a mixture of two liquids? So to obtain two liquids, you need fractional distillation, because you can separate two or more liquids by using different boiling points. So 2 is D. A can't be, because A is used to obtain solid crystals. So it can't. B, it involves the separation of an aqueous solution or molten solution, and normally used in purification of metal. So B is also wrong. C, as you all know that filtration is normally to obtain an insoluble solid from a mixture of liquids. So C is also wrong. So answer is definitely D. Now, question number 3. It says that lead-2 iodide is insoluble in water. So definitely you have the idea of filtration to obtain the lead-2 iodide. So definitely need the filter funnel, which is 4. And here it says 20 cm³ of aqueous lead-2 nitrate. To measure 20 cm³, you definitely need a measuring cylinder. And to pour the lead-2 nitrate to aqueous potassium iodide, definitely need a beaker. So for question number 3 is C. Now for question number 4, it is asking for us to calculate the RF value of substance S. So the formula of finding RF value is this: distance traveled by the spot over distance traveled by the solvent front. And as you can see, Y is the distance traveled by the spot of substance S, and X is the distance traveled by the solvent front. So the answer will be Y over X. And the answer is C. Now, for the fifth question, which row describes the isotopes of the same element? And the definition of isotopes is atoms of the same element that has different number of neutrons but have the same number of electrons and protons. So the answer for question 5 is C. Now, for question number 6, which row describes the structure of the positive ion in sodium chloride? And normally, only metal will form positive ion, which in this case is sodium, which is a metal. And normally, positive ion will lose electrons to form a stable noble configuration. And normally for sodium, since it has 11 electrons, so it will lose 1 electron to form a positive ion. So you'll be left with this configuration of 2 and 8. So the total number of electrons in sodium will only have 10. And the protons will be 11, since sodium is the number 11 element. And the answer will be B. So for now, for question number 7, which statement about copper, diamond, and silicon ivory oxide is correct? First, A. Copper and silicon ivory oxide have similar electrical conductivity. Copper is a metal, so it is definitely a good conductor of electricity. However, silicon ivory oxide is a non-metal covalent compound, so it won't conduct electricity. So A is wrong. For B, in diamond, the carbon atoms are covalently bonded as flat sheets. However, for diamond, they're actually bonded in the tetrahedral arrangement. So it's wrong. C. In silicon ivory oxide, the silicon and oxygen atoms are covalently bonded as flat sheets. Just like diamond, silicon ivory oxide is also bonded in a tetrahedral arrangement. So C is wrong. For D, the structure of copper includes a lattice of positive ions. Copper is a metal, so they are definitely bonded with metallic bonds, which includes a lattice of positive ions surrounded by a cloud of electrons. So D is correct. Now, for question number 8, for this question you have to find the empirical formula. So I'll show you the simple methods of finding the empirical formula for any substance. So here is it. Now, for this question, it's asking us to find the empirical formula of an oxide of nitrogen. And then here you have listed out the percentage composition of nitrogen and oxygen. So firstly, you write down 30.4%, then write down the symbol of nitrogen and oxygen, and write down a percentage. And then the second method, we take the percentage divided by the respective relative atomic mass of nitrogen and oxygen. So for nitrogen, it's divided by its own relative atomic mass of 14. And oxygen is also divided by its own relative atomic mass of 16. So we divide it. So we get 2.1714. And then for oxygen, we get 4.35. Then the next method, we have to divide it by the most simplest ratio. And in this case, it's 2.17, which is the most simplest ratio. So we divided by 2.1714 for both. So ratio will be 1 to 2. So answer will be NO2. However, they're asking us to find for the molecular formula of the oxide of nitrogen. So this will be the following step that you have to follow to find it. Now, as we have found the empirical formula of the oxide of nitrogen, which is NO2, now we'll be finding the molecular formula. So, following the steps that I've given in the video, we'll be using the empirical formula of oxide of nitrogen with NO2. And then we'll equate this to the bracket. And then the bracket will contain the relative molecular mass of the empirical formula of the oxide of nitrogen. And then we'll equate this N, which is the coefficient that will multiply with the empirical formula of NO2, equals to the actual mass of the relative molecular mass of 92. So the relative molecular mass of the NO2 is 46. So to find N, we take N equals to 92 divided by 46, which is 2. So the coefficient will be 2. So we take NO2 multiply with the coefficient of 2 to find the molecular formula of the oxide of nitrogen. So when you multiply it, it will be N2O4. So the final answer. The following is the method to find the molecular formula of any substance. So number 8 is D. So for now we'll be moving on to question number 9, which involves the calculation of moles. So this is asking us to calculate the calcium carbonate reacting with dilute hydrochloric acid. So we have been given the information of 10 grams of calcium carbonate reacted with 100 cm of 1 mole over dm cube of hydrochloric acid. And we're asking to find which statement is correct. So for this question number 9, the method to solve this question, you have to find which is the limiting agents among the reactants of calcium carbonate and dilute hydrochloric acid. To find the limiting agents, you have to find the moles of calcium carbonate and hydrochloric acids. And the formula to find the moles is provided in this video. So these are the two formulas that you will be using to find the answer from in this question. So the first formula is to find the mole from the mass, which is 10 gram of calcium carbonate. So you correct 10 gram on top, and then use 10 gram divided by the relative molecular mass of the calcium carbonate. Then the second formula will be the formula to find moles from concentration and volume. So you take the 1 mole per dm cube from the question times with the 100 cm cube divided by 1000. Then you can find how many moles of the hydrochloric acid. So now we have known the formulas that we need to use in this question, and that the limiting agent is important to help us find the answer for this question. We will be finding the moles of calcium carbonate first. So from the formula, we know that to find the moles of the calcium carbonate from the mass, we need M, which stands for mass over relative molecular mass, MR. So it will be 10 grams divided by the relative molecular mass of calcium carbonate, which is 40 plus 60, 40 plus 12 plus 16 plus 16, over 100 of the mass of the calcium carbonate, and answer will be 0.1 moles of the calcium carbonate. So now we'll be finding the moles of the hydrochloric acid. So find the moles from the concentration and volume. We'll be using this formula of concentration times volume over 1000. So it will be 1 times 100 divided by 1000 equals to 0.1 moles of the dilute hydrochloric acid. However, as you have known from this statement that the limiting agent normally will be the reactant with the least moles, but in this case, both of them have the same 0.1 moles. So now it's important to look at the coefficient in front of the reactants of the CaCO3 and 2HCl. As you can see that CaCO3 is 1 and HCl has 2. So from this, we can deduce that hydrochloric acid is the limiting agent. That is because it takes 2 more of the hydrochloric acid to react with the calcium carbonate. So the hydrochloric acid is lesser in amount. So it needs 2 of them to react successfully with calcium carbonate. So now we have known that the HCl is the limiting agent. So now you can find, and to find the moles and other mass and others information to help us confirm which of the statement will be correct. This 2 and the carbon dioxide is 1. So you'll be using the ratio method a lot in this equation. HCl to CO2, 2 to 1. So there's 0.1 moles of it. So X 0.1 cross multiplication 0.1 over 2x, and then 0.05 equals to x. So we have known that the calcium carbonate, we have known that the carbon dioxide has 0.05 moles. So now using this formula, volume over 24 dm cube equals to moles. This formula is to find the moles using volume, especially from gas. So we have volume equals to 0.05 moles carbon dioxide times with the 24 dm cube. Now let's check. Yes, so it's really is 1.2 dm cube. So the first statement is correct. Now for the second statement. So now let us check the second statement of whether 5.6 gram of calcium chloride will really form. So now once again look at the coefficient at the front, 2 to 1. So write down HCl to CaCl2, 2 to 1. HCl has 0.1 moles, CaCl2 has X. So 2x, 0.1 x, 0.1 divided by 2, 0.05 moles of calcium chloride. So now using the formula, mass over mR, which stands for relative molecular mass, equals to moles. So that's fine. The relative molecular mass of calcium chloride is 40 plus 35.5 plus 35.5, which is 111, equals to how many moles? To 0.05 moles. And to find the mass, just take 0.05 moles of the calcium chloride times with the relative molecular mass of 111. The final answer, you get 5.55 gram. And then here you round up to one decimal place, so we'll get 5.6 gram. So the first statement and the second statement both are correct. Now just in case, let's us check for the third statement. Let's check whether the third statement, whether 4.8 grams of the carbon dioxide will be formed. So once again, look at the coefficient of HCl to CO2, 2 to 1, 0.1 moles of the hydrochloric acid, X. So in the end, we'll get 0.05 moles of CO2. So now using the formula, mass over relative molecular mass equals to moles. The relative molecular mass is 16, is 12 plus 16, 16, 44 equals to 0.05. So times 0.05, you get for the mass of the carbon dioxide is 2.2 grams. So the third statement is wrong. So for fourth statement, no calcium carbonate is left when the reaction is completed. This is false. That's because hydrochloric acid is the one that is limiting it. So it is actually the hydrochloric acid that will be affected. So in the conclusion, the first and second statement is correct. So after doing all of these calculations, we have known that the first and the second statement is correct and the third and fourth is wrong. So the answer will be A. Alright, so now for question number 10, which substance is not produced during the electrolysis of concentrated aqueous sodium chloride? So firstly, we need to know what is electrolysis. Electrolysis is the breaking down of the ionic compound in the aqueous or molten solution. And here the ionic compound is sodium chloride, so it will be decomposed to produce the Na plus and Cl minus ions. And we should not forget about the word aqueous. That means it contains water. So water contains H plus and OH minus ions. So now thirdly, we need to see the word concentrated. So this means that the Cl minus will be the one that will discharge instead of the OH minus. And then since H plus is lesser reactive than the sodium ion, so you'll be discharged easier than the sodium. So hydrogen and chlorine will be released. Now look at this, Na plus and OH minus are left in the solution. So they will be joined together to form sodium hydroxide. So it will also be produced. So the answer will be C, because sodium is not produced, because sodium is more reactive than hydrogen, so it will not be discharged at all. So now for question number 11, it also involves electrolysis. So for this one, it's quite different because normally we'll be dealing with carbon electrode, but this time it's copper electrodes. So normally you only involve the copper ion in the electrolysis. So normally for anode, the oxidation will occur, and oxidation is the loss of electron. And normally is represented by this half equation. And cathode is where reduction will occur, and reduction is the gain of electrons. And this is the half equation of the reduction half equation. And this is because only copper will be involved, because this is copper electrodes, and only will the copper ion will be involved in this electrolysis. So the for question number 11 is A. So now for question number 12, look at the information. 10 grams of ammonium nitrate is added to water at 25 Celsius, and the mixture is stirred. And after 1 minute, the temperature of the solution is only 10 Celsius. So as you can see, this is a decrease in temperature, the surrounding temperature. So from this, we can conclude that this is an endothermic reaction. That is because endothermic will normally causes the temperature of the surrounding to decrease because they takes in energy. So now for this question number 13 is ask you have to see that the word is exothermic. So which statement about this reaction is correct? So energy is released during bond making, and energy is normally taken in during bond breaking. But now is exothermic reaction, so the enthalpy change will be normally be negative, and that means the products at the end of the reaction is lesser than the reactants, which means more energy is released than taken in. So the answer will be B. So now for this question, it's talking about hydrogen oxygen fuel cells, and it's asking about which statement is correct and is an advantage of hydrogen oxygen fuel cell. And now it's looking at advantages. As you can see that A, B, and C, they are all disadvantages. So that leaves us with D, which is an advantage. And the only product that is being made is really water, as only hydrogen and oxygen is reacting with each other to produce water. Now, for question number 15, a student adds dilute hydrochloric acid at two different temperatures to two different lumps of limestone, and which row describes and explains the result obtained at 50 Celsius compared with 25 Celsius. The reaction rate will definitely be higher, since that at a higher temperature there will be more energy supplied uh, to the particles, and the particles gain more kinetic energy. Moreover, there will be a higher energy of collisions as the particles have more kinetic energy at higher temperature. So the energy of collision will be higher also. So for number question 15 is B. Now, for question number 16, which reaction is reversible? The answer will be D, because as you know that copper sulfate is actually can be reversed from anhydrous copper sulfate to hydrated copper sulfate. So the answer will be 16, will be D. Now, for question number 17, some nitrogen dioxide gas was put in the gas range, and the end of the gas ring is sealed. And this is a reversible reaction. And then the forward reaction is exothermic. Now, for normally for a reversible reaction, when the forward reaction is exothermic, the backward reaction will be endothermic. Now, let's check which statement about the reaction is correct. The gas range is placed in the cold water bath, the color becomes darker. Well, when it's placed in a cold water bath, it has a lower temperature and you will not favor the backward reaction. You actually shift to the forward reaction. So A is wrong. B. If the gas range is placed in the hot water bath, color becomes lighter. Well, because when it's placed in the hot water bath, there will be more heat energy. And then remember that endothermic will normally take in heat energy, so it will normally shift to the backward reaction. So the color will become darker. So B is also wrong. Now C, we need to apply the concept of Boyle's law, where pressure and volume is inversely proportional to each other. When the pressure increases, the volume will decrease. And then we know this concept where the pressure will favor the side of the reaction with fewer moles. And for C, if the volume in the gas stream is increased, the color becomes lighter. As you can see, at the forward reaction, it has fewer moles. And then for the backward reaction, it has more moles. So C, volume increases, and then the pressure will normally decrease. So you actually shift to the backward reaction. So the color becomes darker. So C is also wrong. Now, if the pressure in the gas stream is decreased, the color becomes lighter. As you see, when the volume decrease, the pressure will increase. When the pressure increase, you'll favor the side with the fewer moles. So the answer for question number 17 is D, that the color will become lighter. So now, for question number 18, the reaction between magnesium and carbon dioxide is shown in the equation, and which statement describes what happens in this reaction. So first, we have to know that oxidation state increases when oxidation occurs, and oxidation state decreases when reduction occurs. Now let's see. A, carbon is oxidized. Well, this is wrong because here at the reactant side, the carbon is 4 plus. Then when it's at the product, it becomes 0, and oxidation state decreases. So this means that reduction occurs instead of being oxidized. And here, magnesium is reduced. Here, as you can see, magnesium here is 0 at the reactant side, but here is 2 plus. So the oxidation state increases when oxidation occurs. So magnesium is oxidized instead of being reduced. And by the way, oxidation can also say be the addition of oxygen. And 18, C, neither oxidation nor reduction happens. This is wrong because this is actually a redox reaction. So C is also wrong. Now, leave with D. The carbon in carbon dioxide is reduced. It's correct because at the reactant side is 4 plus, then we go to the product side is 0. And this means that the oxidation state decreases, which means that reduction has occurred. So D is correct. So 18 is D. Now, question number 19. Which changes involve reduction? Well, for number 1, this is actually an oxidation. This is an half equation that represents oxidation. And number 3 is a half equation for reduction. So 3 is correct. So number 4 is actually it's just only a combination of both of the ions to form a lead sulfate. So 4 is also wrong, and 1 is wrong. Number 2, CuO plus H2 to Cu plus H2O. Now let's check as the oxidation states. So you can see here is 2 plus, and here becomes 0. And in this case, the copper in this copper oxide is being reduced because its oxidation state decreases. So 2 and 3 is correct. So for number 19 is C. Now, for question number 20, this involves the neutralization reaction knowledge. So let's look at the details. Barium hydroxide is an alkali and reacts with hydrochloric acid. And how does the pH of the hydrochloric acid changes as an excess of aqueous barium hydroxide is added? So as you can know that barium hydroxide is an alkali, which causes the pH number to increase. So let's have a look. So as you can see that it's an alkali, it causes the pH to increase. So automatically A and B is wrong. Now leave with C and D. Since this is in an excess, so you want to reach the neutralization pH of 7. So you instead increase to pH 14, since barium hydroxide is a strong alkali. So for number 20 is D. And that concludes the end of the part 1 of the chemistry paper, February-March 2019. Thank you for watching. Have a nice day.